video focuses on permutations and factorials. Here's the definition of a permutation. We want to think about, when you hear the word permutation, I have in parentheses here, arrangement. The definition is a way to select a group of objects in which order is important. All right, so here's an example. How many ways can the letters A, B, and C be arranged without replacement? So what we have here is a tree diagram. So we're going to start with the letter A, and then we're going to choose the next letter. So we could have it start with a B, then an A, or an A and a B. And we choose the next letter, C. You'll see the tree heading out here. So we could have it CBA, BCA, or BAC. Then the next tree with branches could be CAB, ACB, and ABC. Well, we use this thing called factorials in just a moment. I'm going to show you where this is the first choice permutation, and then we multiply it 2 times 1. So now you see if we just had A and B, how many choices could there be? 2. Now we have 3. So we could say 3 times 2 times 1. And you'll notice 3 times 2 times 1 is 6. So underneath here is the introduction to what we say a factorial. So we have the 3 times the 2 times the 1 is 6. This represents 3 factorial. How many different possible ways can we rearrange the order of the 3 letters A, B, and C? And they're all listed out right here. 6 different ways. All right, here is the definition of a factorial. The factorial of a number is the product of natural numbers less than or equal to the number 0. So I think it's probably better to show you with an example for you to be a little bit more clear. When you say 6 factorial, you start with the number 6 and you multiply all the way down to 1. So you get 720. Now we will show you how to do this with your calculator too, but right now just understanding that if you say 6 factorial, you multiply all the numbers from 6 down to 1. All right. We also have this example here, which I like, is let's say you want to divide 2 factorials together. So you have 7 factorial and 4 factorial. Notice what happens with 4 to 1 and 4 to 1 in the numerator and the denominator. They cancel each other out. So you're going to see later on in some of our problems where that happens. So we just have to worry about 7 times 6 times 5 because the 4 factorial pieces cancel out. So we just have 210. All right, here is a formula and an example. So I'm going to start on the right-hand side. This is our formula for permutation. So we just talked about that example of the letters A, B, and C. I figured how many different ways can we rearrange the order? So we said it was 3 factorial, or 3 times 2 times 1, which is 6. We can also use a formula. And the formula will look like this, 3p3. So we're choosing 3 of them. All right, so here we go. So here's our example. If we have 7 items, so think about 7 letters, and we only want to have groups of 3. So if we have A, B, C, D, E, F, and G, and we only want 3 letters at a time. So maybe you want these 3 letters, and then those 3 letters, and then these 3 letters. Well, that would take us a long time to figure out. Well, we can use this formula instead. What the formula says is you start with the number of total items. So how many items do we have? 7. So that's our first number. And then how many do we want to choose? We're choosing 3 at a time. So that is your second number here in the little. So now we substitute into our formula on the right. So you'll see 7 factorial over 7 minus 3 factorial. then we can go ahead and solve that problem. So we did this already, but I just want to review with you. 7 times 6 times 5 times 4, and I'm going to just leave it as a factorial. Then divided by 4 factorial. Now remember, those two guys canceled out. So we only had to multiply 7 times 6 times 5. We will show you on a graphing calculator also how to take this equation here and substitute into your calculator and figure that out. But I don't want to do that quite yet. All right, here's another example. Now we're going to go ahead and try this together. So imagine we have a student government. We have a president, a vice president, a secretary, and a treasurer from a group of 6 people. We want to figure out how many different ways can we rearrange the order. So we'd start off with how many are in our group. There's 6 people. So 6 is our total permutation. And then how many people are we going to have in our group? So we have a president, a vice president, a secretary, and a treasurer. So we have 4 people in each of our groups. So we're going to go ahead and substitute that into our formula. So 6 factorial over 6 minus 4 factorial. Now we simplify it. 6 factorial in the numerator. 6 minus 4 is 2 factorial. All right, now we're set to go. So I'm going to go ahead and go from 6 to 5 to 4 to 3 to 2, and then I'm going to stop because I have a denominator of a 2 factorial. Go ahead and cancel these. Now we're going to go ahead and multiply 6 times 5 times 4 times 3. And we get 360 different ways that we could rearrange the order of who is president, vice president, secretary, and treasurer from a group of 6 people. All right, let's try one more. Awards are given out at a costume party for the most creative, the silliest, and the best costume. And there are 8 people at the party. So we have our total of 8 and a permutation, and we're choosing 1, 2, 3 different awards. So substitute in 8 factorial, 8 minus 3 factorial, so 8, 7, 6, oh, I probably should do 8 minus 3 is 5 factorial, that's fine. Probably getting the hang of this. All right, so I stopped at 5 factorial in the numerator. I stopped at 5 factorial in the denominator because that's what it is. And now I multiply 8 times 7 times 6. And we get 336 different ways that we can rearrange the awards for these 8 contestants at the party.